by more and more adoption of artificial intelligence, right? So today's what we're broadly going to cover in this topic is a short history of AI. We'll talk about what is artificial intelligence, what are the different definitions, and different approaches to AI, right? I mean, AI got different approaches. It's not one strat-beat approach which we are following to crack problems in AI. So what are the different approaches to AI? And then finally, of course, why AI? I mean, why are we talking about AI? What does it really give either to the business or to the government as a value add? So what is it that we get from there? And at the end of the day, we are talking of intelligence, right? So we want to see what are the human brain analogies and what is it that our system should do to be more and more intelligent. So that's where that particular subtopic comes in. We'll look at the applications, the stages of AI, and the domains of AI. I mean, which are all the main domains of AI, where we'll talk about machine learning and things like that. And finally conclude with what are the broad career prospects in artificial intelligence. We'll keep that piece short. So I hope to finish this in about 40-45 minutes. And after that, if there are any questions, we'll take them. So going on, artificial intelligence really has been something which has been talked, in fact, right from Greek mythological times. But coming to more modern times, 1950 was when what we have, devised what is known as by Alan Turing, called the Turing test, which is a method of determining whether a machine is intelligent or not. We'll talk more in detail down the lecture on this. But that's when something was started. And then 55, 56 is when the term artificial intelligence really came into being used, right? And then in 66, we had the first chat bot which simulated the conversations of a psychotherapist, right? And so there was if in the 50s and early 60s, there was some lot of interest in artificial intelligence, lot of it from academia and things coming out of the academic circles, right? But going on from 70s to 80s, which sort of broadly, which is known as a AI winter, which is really not great progress in artificial intelligence in that area. But however, coming to 1997, we had the Deep Blue, which is a chess computer, and it won against Garry Kasparov. All of you must know him. He was a world champion in chess. And then, of course, 2011, Siri as an intelligent speech agent was, first integrated in the iPhone 4. And then we have the Watson, which is a supercomputer. It won a game called Jeopardy against two human rivals at the same time, right? And of course, then we had Alexa, Tay, AlphaGo, and various things coming up. And it's really now speeding up in the from 2014-15 onwards. The progress in AI is really sort of speeding up. So that broadly is the history of AI. I mean, how we have made progress in the last 50 to 70 years, right? But let us just take a step back and see why are we really talking about AI at this stage in technological development, right? So AI has been there, like I said, from the last almost 70 years. We've been talking something or other about it. But we have been able to make strides in AI and also make a lot of progress primarily because of more computational power, right? The systems which we have are really having very high computational power, and with very small footprint, we are able to generate a large amount of computational power. So that's one thing which has been making it easy for us to make progress in AI. And of course, the second piece is availability of data, right? The Internet of Things has ensured that we have got a lot of data available. There has also been a lot of progress in storage, right? So storage, computation facility, capability, and availability of data, right? Ability to capture data, store it, process it, which has made it AI more and more relevant now. We of course have better algorithms, software. Computer science has developed in a major way, so we have much more efficient algorithms today. And based on all this, there is more and more investment. So it's always like if you have investment, you have progress. And and nobody makes an investment unless he sees that breakaway point of progress, right? So we are now in the breakaway zone of progress in artificial intelligence, and therefore more and more countries and corporates are investing in artificial intelligence. Should I go ahead further? Okay. So what exactly is artificial? I mean, it's a very loose term. I mean, if you look at it, right, it's making computers that think, or automation of activities which should associate with human thinking, like decision making, learning, etc. The art of creating machines that perform functions that require intelligence when performed by people. So again, we define this as when a person requires intelligence, he's not doing it rote. For example, if we are generating a payslip, right? It's really not intelligence involved. It's a standard set of rules which we follow and generate the payslip. So there's no intelligence required. Even a human does not require intelligence. He just uses a set of rules, knows mathematics, and just does those calculations. So that would not be artificial intelligence, but where we sort of deduce and see what is the best alternative and do that, then we are saying, or when our payroll system is able to really come out with, for this type of a person, this should be the ideal pay we should be offering based on a numerous number of fungible and non-fungible conditions, then that particular system is more is an intelligent system, right? The study of mental faculties through use of computational models. And so this is a little dated when a lot of cognitive science was mixed up with artificial intelligence, but today there are two different sciences which are progressing in parallel. So again, I mean, looking at a similar but slightly variations on this, like study of computers will make it possible to perceive, reason, and act, right? So that's a major thing. I mean, we should be able to perceive, reason, and find out what is the best possible solution to a given situation and act on it. And that's how human work, and that's how an artificial intelligence system should work, right? A field of study that seeks to explain and emulate intelligent behavior in terms of computer process. I'm sorry for that. So all of this are sort of different ways of looking at what artificial intelligence really is. And finally, of course, anything in computer science that we don't know how it works to do properly is artificial intelligence. So yeah, so these are the vision. But more formally, right, the first person who defined artificial intelligence was a person called John McCarthy, who coined this term way back in 1956. And according to him, the science and engineering of making intelligent machines is artificial intelligence, right? So again, there are terms. What is an intelligent machine, which need to be further dwelled into. But that's how he sort of looked at what is artificial intelligence. And the more modern times, when we talk of what is artificial intelligence, is sometimes called machine intelligence. Intelligence demonstrated by machines in contrast to natural intelligence displayed by humans and animals, such as learning and problem solving. So if a machine is able to learn and solve a problem, we call it artificial intelligence. Another definition is study of intelligent agents, any device that perceives its environment and takes actions that maximize chances of success in achieving its goals. Right? So perceiving the environment, that's the critical thing in this, to know what the environment is and come up with the right solution and take action accordingly. So that's really is what is artificial intelligence. So these two are the more formal sort of definitions of artificial intelligence as we look at. So we'll now quickly look at the different approaches to artificial intelligence, right? So one is a human approach, the other is a rational approach, right? So when we want to mimic human behavior, right? Not the human thought, the way human behaves, not necessarily how a human thinks, right? They're two different things. So if you are trying to mimic human behavior in a system, that's called that's one approach, right? And that's where the Turing test approach comes. We'll talk about Turing test a little later, but that's when you say when you have a machine performing a task and a human performing a task, you don't see a difference. That's a human behavior, right, of a machine. The second piece is approach is the systems that thinks like human, which is where the cognitive models come in, right? A lot of research has gone, and parallelly, a lot of neuroscience, cognitive science, thought process, how the brain works. So that sort of approach to artificial intelligence was going on. It's a little slower now in that respect, but research is going on in this direction. So that is one approach to how we can build an artificial intelligence system. The third approach is systems that think rationally, right? What is rational? Rational is the correct way of doing things. The system which thinks rationally, the correct way of it. So if you are able to, capture how a human thinks in a particular situation and build it in a system, in a machine, a similar thought process, technique, that's called law of thought approach. Some of the expert systems, like long back, we used to have expert systems for a much average form for a doctor or a homeopath and things like that, which would ask a few questions and then prescribe something, right? These are basically, you capture the knowledge of a person and build some rules around it, right? And then build the whole system. So it is limited to what the expert is able to say. So that's a law of thought approach. And the final one, which is probably one which is more in vogue these days, is the systems that act rationally. This is the rational agent. That, like I again will repeat it, a rational system is one which acts correctly. So a system that acts correctly, it need not think correctly, but given a particular situation, it should be able to take the most appropriate and correct, solution to a given problem under those conditions, and act on it, right? So that is the which is called a rational behavior system, right? So most of our AI progress is a large piece is towards the approach which we call as the rational agent approach. Do you have any questions here, or can we go ahead to the next portion? Okay. So why is artificial intelligence useful, right? I mean, why are we spending so much and doing so much of research on artificial intelligence? The first and foremost thing is automation, right? Ability to automate a repetitive task that was previously done manually. And previously done manually, one was which is purely by rules, and the second one is which requires some intelligence. So even now, if you automate the ones which can require some intelligence, we are able to take out the errors in the system, right? Human beings are prone to do errors over a period of time, right? Fatigue sets in, and this expertise level from one human being to the next human being could be different, right? Like I'm just giving you, as we go further, we look at, for example, images and maps, right? So if you have to interpret a map or an image, two human beings would probably do it slightly differently from each other. Whereas if we are able to automate it, and you will get a much more consistent and more accurate sort of result out of it. So that's why that's one of the very major advantages of artificial intelligence. And then enhancements, right? We can make our products and services much more effective and improving the experiences for end users, basically by learning. How does it? So when we build a system, right, initially, for example, if I'm a very I'm giving you a very rough example of, I want to design a water heater, right, water kettle, and I have certain assumptions now how a person will use a water kettle, and I design a system based on that. My assumptions may be right, may not be right. In a typical product company, what they would do is they would get a feedback from the customer, right? And the customer generally gives a feedback, sometimes give feedback, sometimes doesn't give feedback. His feedbacks don't make, sometimes do not make enough, he may not be putting enough thought into his feedback. However, if we are able to, capture his experience, how does it operate? We may have thought of certain sequence of operation, right? For example, a microwave or anything, but that may not be what the customer may be doing repeatedly. So if we are able to capture it, bring it back, analyze it, uh, and then we can optimize this, right, and make our product much better, and therefore be much more competitive in the market. So that's where one of the major, place where AI plays a role is these agents who are sitting on our system, on how customers interact with that, or so pick up from there and keep on, sort of improving our service and our offering to the customer. Conversation bots is a typical example. When we think these are the five things which customer would require. But if you are able to capture, store, analyze what the other inputs have come from the customers, in the next iteration we can make a much better conversation bot, right? So that's a very significant advantage of application of AI in product development, right? Analysis, right? AI can analyze data at a much faster rate than humans, allowing me to find patterns more quickly. So once it learns how to analyze, it does it much faster and much more accurately, right? For example, if system is taught how to read a map, then if you have a satellite run and get you get reams and reams of map which comes gigabytes of data, this will be analyzed much faster by an AI system than can ever be done with humans, right? And we talked about accuracy, right? They can be trained to be much more accurate than humans. It can be trained to be much more. We got to keep that in mind. We need to have a well-trained, accurate AI system. Only then we can say that its accuracy is better than humans, right? Otherwise, it can be, at fault when you make that statement like that. And finally, of course, return on investments, right? AI, it maximizes the value of data, able to better job analyzing the complex multi. So the AI is able to pick up relationships between data which we cannot see, right? So, and that is where a lot of these retail people and even pollsters use artificial intelligence to really grab at data and analyze data to come up with certain correlations, and what type of correlation people with this age group who are from this area vote in this pattern, things like that. I mean, some things are seem very simple, but an AI system would come with a much more complex and a strong, dependencies between data, which would otherwise be not clear to the naked eye. So these are the primary reasons why AI is very useful in today's world, in both business and in government and other applications. So typically, if we are if all of us are going to go and build a artificial intelligence system, we need to know and we need to understand better why humans are intelligent, right? And why do we say humans are intelligent? So basically, humans are intelligent because of their learning, ability to learn, ability to reason, right? Given four different options, we are able to find out which is the right one and reason as to why that is the right one, right? Problem solving and creativity, right? We are able to solve problems, find the right approach, and how we can solve it. And also creativity, right? Creativity is really how a man is differentiated from animal, right? How we can come up with new things, and that's how the human race has progressed over a period of time. Right? Social behavior, of course, and how we behave in society and things like that, and also the fact that we are all the time experiencing our environment with our senses. Sometimes we are, we are very aware of it. Sometimes we are probably very not aware, but a lot of our decisions are based on what our sensors are picking up: hearing, sight, touch, taste, and smell. Right? What they are picking up. Right? So these are probably some of the major things which form a necessary part of an artificial intelligence system. Right? And now when we delve deeper and they say, how do humans learn? So if I have a problem, I think of a past situation, right? I mean, how have I solved it? Can I solve it the same way? So, and also if I take an action, I should know what I always try to anticipate now what is going to happen next, right? Because if you don't anticipate, then the next time around we are going to fail, right? So that's the thing which I'm like. Now, and if we fail at something, right, and then we sort of imagine how should we have done differently, right? So that is where artificial intelligence systems need to be doing, right? You could get it wrong once, but how did the wrong output come? What are the conditions? What are the environment? What are the inputs? How did it get it wrong? And what should be the next course of action, right? Those are the things which ability to bring it back, rationalize it, and improve the system. That's what artificial intelligence systems is. So these are the primary things like how humans learn and how human brain works, and therefore what should be a typical artificial intelligence system. We should have sensors, picking up the environment, picking up where and in what type of environment we're making a decision, what type of inputs we are getting, how to analyze it. If we do it, I mean, how have we done it past? Be able to store previous experiences, use it for the for future, and if we have failed in some endeavors, store that back, analyze it, and see how better we could have done. So that's what the whole artificial intelligence system would be probably be doing. So we just talked about Turing test. I said we'll cover it. I mean, it's a test to determine whether a computer has achieved intelligence. So this is what Alan Turing said, right? And if he said if a machine passes this test, then he says that it is really intelligent. So this is how the whole thing, according to him, would work. There would be an operator who would be interrogator, who sort of be asking those questions, and you will have a human and you will have a machine responding to that. And the time when the interrogator does not know whether he is getting an input from a machine or from the human, then the machine is intelligent, right? So that's what the Turing test. So none of our systems really pass the Turing test fully. We have systems which are in a very small domain able to pass the Turing test to a large extent, but still we do not have anything which can pass the Turing test in all its domains and as a full-fledged artificial intelligence system. Any questions here? So we have talked about this piece again, a little ahead of this. What are the drivers for AI? Is low-cost chips and large-scale neural networks. We'll talk about neural networks a little later. And limitless training sets. I mean, training sets are basically a huge amount of data which we can use to train our system, right? Train an artificial intelligence system. So these are the primary drivers for artificial intelligence. Now, applications are really mind-boggling. I mean, I would say there are very few applications today which do not use artificial intelligence in one form or another. Whether it is natural language processing, right? We have Alexa, Siri, all those virtual personal assistants, which we have in most of these travel sites and other places, right? And then social network analysis, whether it be Facebook or Twitter, all of them use artificial intelligence to analyze at individual level, at societal level, at subgroup level, how things work and what should be their, how to make their services better. Of course, robotics is a thing where, which is primarily driven through artificial intelligence. Image analytics, whether it is face recognition, image recognition, or at a larger scale, maps and things like that, right? So a lot of military applications have been ahead of the civilian applications in terms of image analytics, right? Image analytics has been much more, used, especially for, decoding a lot of satellite imagery. And, we have these reconnaissance missions by aircraft and by UAVs, across the borders and things like that. So at one time, all of this data used to be analyzed by humans. So, but really now the amount of work in this area which is being done is so much that humans cannot really be used to fully analyze everything, and it's mainly done through artificial intelligence, right? Visualization, audio analytics. So the applications of this are sort of something which is mind-boggling, and I don't see if we can come up with areas where we can now say that this area does not use artificial intelligence. It's hardly any like that. Okay, this is a short video. If people have seen it, let me know. I will stop it. We'll not waste our time on this. But I'm playing it. This is on Google Duo. So if people have seen it, 60% of small businesses don't have. Have people seen this before? Are you able to hear me, please? Audience?
Yes, sir. Yes, sir.
So have people seen this, or should I just go ahead and play it? Have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
How can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa.
So when you see this whole example, right, one piece, of course, is ability to understand the language, right, like Siri or anything does. And the second piece is able to find out, to understand the context, understand the thought behind it, and able to provide options and solutions based on that. So this is really the next level of artificial intelligence which we are seeing now.
Okay, perfect.
Okay. So applications of AI further, like it's really like I said, there's no real one area where it's like thinking, like even machine learning is being used in making pesto sauce more delicious, because they're improving the flavor of the basil by using artificial intelligence in farming, right? And of course, medical has got a huge application of artificial intelligence, both in performance of surgery and in radiology and analysis of test data. Okay, so once we've looked at AI, but the stages of AI, I just want to briefly cover to understand to all of you to understand that where are we in terms of artificial intelligence. So the first stage of AI is called artificial narrow intelligence, or the weak AI. Abundant data time. A nice way to describe AI is superhuman or specific similar tasks. Okay, so AI which is able to do specific similar tasks really well. So this is where we really are in terms of artificial intelligence. So at the best of our systems can only come under the category of artificial narrow intelligence. The artificial general intelligence is strong AI, which means the machine be capable of understanding the world as well as any human, right? We are able to do so many different things. So that's that. I mean, we have artificial intelligence systems, we have robots which are able to do specific tasks, right, better and as good as even probably better than humans. But we do not have a system today which can think and act like a human being in all the contexts which we are able to do. So the artificial general intelligence is not amongst us. It's a hypothetical form of AI. Maybe it's somewhere down the line. And artificial super intelligence is where the AI systems are way better than humans. We see it in a lot of movies, and we really don't know when it's going to come. And we hope a time like that doesn't come soon, right? Not in our lifetimes. Okay. We'll quickly touch on how are we doing on time. Ma'am, how are we doing on time? We have got another 10-15 minutes.
Yes, sir. It's a maximum of 1 hour, sir.
Okay. I'll take another 10 minutes. So, yeah, thank you. So the domains of AI, like machine learning, deep learning, robotics, expert systems, fuzzy logic, natural language processing, and computer vision. These are broadly, there are many more domains which are coming up new, but in a very but at a very high, these are the domains of AI. Right? But when we talk of an AI, one of the major things of an AI system is knowledge presentation, ability to store knowledge in the system, right? So we need to create a logical view of data based on how we want to process it. Natural language is very descriptive and does not lend to efficient processing. So we should be able to store it correctly, right? So the various types of systems we can use. First thing we had talked about expert learning systems. We'll talk a little more on that. And then semantic networks, and then decision or search trees, and finally neural networks, right? We'll quickly look at what each of these are. Expert learning systems they were commercially available first and most successful in artificial intelligence domain, and somewhat out of favor today because the problem is to capture all the intelligence in a particular field and then able to code it in terms of into an expert system. There are limited things which we can do with this. So there are different type of expert systems which have come about. All of them are somewhere there, but not fully there, right? So that's what expert systems are. The second is semantic or word description networks, and it focuses on relationship between objects, right? A directed graph or word chart is used to represent a semantic network. For example, student is a person and has an eye color. He has a student ID number. So you would create a network like this for a particular and store data in a network like this, right? Those are called semantic networks or word description. And finally, the third piece is the search trees. We are all very familiar with trees and computer science, right? And these are, complex algorithm built on top of another. So when we are not talking only data stored as trees, but algorithms which are in a tree format, and we bring into focus the algorithm which is required at any particular instance of time, right? And we can drill down in this. So algorithm stored in a search tree pattern. And the one which is sort of making more and more inroads is this what is known as artificial neural network. Again, we are talking about in a very fundamental way and in a very short. This is really a topic of much more detailed discussion. But these have been sort of neural networks are inspired by the characteristics of human brain. So in a human brain, we have got what is known as neurons, and a neuron accepts inputs from multiple neurons, right? And it is able to attach a weight of the input from different neurons and then come out with a final answer on how to activate itself, right? So all neurons which are as though the output of a neuron is sort of yes or no sort of a thing, but it is able to attach, our human brain is able to attach, a human neuron is able to attach a weight to the different neurons differently. and thereby bringing in the intelligence piece, right? So to see how really it can work. So artificial neurons commonly cause processing errors are modeled on after neural neurons, and as multiple inputs, one output, the inputs are signals that are strengthened or weakened, right? Which are basically you can attach weights to this. If some of the all signals is strong enough, the neuron will put on a signal 1. Okay, and this is how if okay, and this is how we train an artificial intelligence system. So we should be able to go back and see what is the weightage to be attached to different neurons, right? Different the neural network. First thing, the neural network itself is complex, and then we will go and sort of tune the weight attached to each of these neurons to get the right output, right? So that's what is called a training of a system. So when I say I'm trying to train a AI system, you're basically trying to train the neural network and trying to see what should be the weightage attached and what is the right time where it's tipped and should be given a positive output. So the process of adjusting weights and threshold values in a neural network is called training, right? So to really recognize an eagle in a picture, it is output of pixel 1, train network to produce an output of pixel 1 for every pixel that contributes to the eagle, and 0 that doesn't, right? So that's how it's a very simplistic way of saying things, but neural networks allow us to go back and train the system by adjusting the weights, right, and coming out with the right outputs. Let's talk quickly about machine learning. Machine learning is basically a subset of artificial intelligence in computer science, right? And deals with study and use of data and algorithms that mimic how humans learn. This helps machines gradually improve their accuracy. So again, machine learning is primarily propelled by data mining, a lot of data mining, classification, neural networks, and ability to train the system over and over again, which is the learning piece of it, and improve the performance of the system. So that's primarily what is machine learning, right? Optimize the performance criteria using example data or past experience, inference from example, role of efficient algorithms to solve the optimization problems. So machine learning is used when human expertise does not exist. For example, if you have to navigate on the Mars, one human element doesn't exist. So we should be able to use machine learning through that. When humans can't explain their expertise. For example, speech recognition, right? How do we recognize speech? We don't know really. So that's where we use machine learning. We use some cognitive models, and after that, we are able to build neural networks on top of the cognitive models to come up and train the system, right? And then models must be customized, personalized medicine, and models are based on a huge amount of data. So that's where you typically use machine learning. And like I said before, that if you have to calculate payroll, you really don't need to learn. And there's no machine learning involved in those things. The types of machine learning are supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. The definition, the very word itself tells you what it is. Supervised learning is the machines. Yes, please. Can I go ahead? Okay.
Yes, sir.
Okay. So supervised learning, machines are trained by examples. Unsupervised learnings, machines themselves examine the data to detect trends. So in supervised learning, you will have an expert on the system who will be, classifying data, labeling data. And so in unsupervised learning is mainly unlabeled data, right? The system tries to learn on its own depending on how the outputs are. Semi-supervised learning is when we using both labeled and unlabeled data, and reinforcement learning is concerned with regimental learning procedures in which machine learning algorithm is given a set of actions, variables, and values to follow, right? So these are the actions to be taken. This is the end value to be reached, and and from there the system learns how to go. So we'll look at quickly a look of machine learning from in a drone design problem, right? And how and the tremendous advantage it gives to designers.
And algorithms to synthesize geometry, to come up with new designs all by themselves. All it needs are your goals and your constraints. I'll give you an example. In the case of this aerial drone chassis, all you would need to do is tell it something like it has 4 propellers, you want it to be as lightweight as possible, and you need it to be aerodynamically efficient. And then what the computer does is it explores the entire solution space, every single possibility that solves and meets your criteria, millions of them. It takes big computers to do this. But it comes back to us with designs that we, by ourselves, never could have imagined. And the computer is coming up with this stuff all by itself. No one ever drew anything, and it started completely from scratch. And by the way, it's no accident that the drone body looks just like the pelvis of a flying squirrel.
So if you look at this, right, I mean, it's an artificial intelligence system throws up millions of alternatives which we can pick up from. A design engineer would not be able to himself, think about so many variations, right? He would really pick up an existing design, see what are the shortcomings in the design, and see how best he can improve on that. But to come up with absolutely revolutionary design, this is the best way to go forward. Right. A quick word on deep learning. This is a new area of machine learning research, making it more and machine learning closer to artificial intelligence, right? And it uses deep neural networks in the brain. It studies deep neural under this perspective and to emulate the functions of the inner layers of brain. So it's really trying to learn from how the brain works and use it. Since deep learning methodology technology is modeled after the human brain, each time new data is poured in, the capabilities get better. So deep artificial networks are a set of algorithms reaching a new levels of accuracy for many important problems such as image recognition. So artificial intelligence is a superset, right? Machine learning is a subset, and a subset of machine learning is deep learning. Software to train itself to perform tasks, right? Like speech and image recognition. So that's what is deep learning, right? Instead of having anybody else trying to train it, it trains itself. So we look at this deep learning example quickly.
Deep learning and machine learning both offer ways to train models and classify data. This video compares the two, and it offers ways to help you decide which one to use. Let's start by discussing the classic example of cats versus dogs. Now in this picture, do you see a cat or a dog? How are you able to answer that? Chances are you've seen many cats and dogs over time, and so you've learned how to identify them. This is essentially what we're trying to get a computer to do, learn from and recognize examples. Also keep in mind that sometimes even humans can get identification wrong, so we might expect a computer to make similar errors. To have a computer do classification using a standard machine learning approach, we'd manually select the relevant features of an image, such as edges or corners, in order to train the machine learning model. The model then references those features when analyzing and classifying new objects. This is an example of object recognition. However, these techniques can also be used for scene recognition and object detection. When solving a machine learning problem, you follow a specific workflow. You start with an image, and then you extract relevant features from it. Then you create a model that describes or predicts the object. On the other hand, with deep learning, you skip the manual step of extracting features from images. Instead, you feed images directly into the deep learning algorithm, which then predicts the object. So deep learning is a subtype of machine learning. It deals directly with images and is often more complex. For the rest of the video, when I mention machine learning, I mean anything not in the deep learning category. When choosing between machine learning and deep learning.
Okay. Just a quick word on computer vision and NLP. Computer vision area with a lot of application of artificial intelligence, and if you see around, really this area is sort of improved by leaps and bounds. Whether it's maps and cartography, whether it is recognition of human face applications in our own iPhone, or when we go to a check-in into the check-in counter in the airport, all these areas, right? I mean, computer vision is really the area where artificial intelligence applications have really made the systems cutting edge, right? And the second piece is natural language processing, and this is something I don't think any of you needs any introduction to. Siri, all of you are aware of, ability to recognize speech, understand speech, and of course, like we played the Google video where it brings the next level of artificial intelligence, where understanding and choosing the right choices and coming up with solutions. So, natural language processing is fundamental to a lot of innovations which are taking place. We have natural language processing, but a lot of scope is there for all of us to work in these areas. Right? So, looking quickly at tools which are popular and programming language, Python is probably one of those. Anybody who wants to be in the field of AI should know that and should understand that. R, from a very data processing and applications perspective, and even Excel has got some good AI modules embedded into that. If you are if you're looking from pure engineering standpoint, MATLAB is an area which a system which integrates a lot of AI tools into that. So depending on your applications, I would say an AI engineer, Python, R, MATLAB, if you're looking at engineering, are fundamental things which we should all be pretty familiar and good at. Okay, so a quick look at job profiles. I picked this up from somewhere. Some of them maybe not be very, machine learning engineer, data scientist. Data scientists, of course, all of you are aware of. I think a lot of openings, etc., available here. Artificial intelligence engineer, which is a much broader thing than purely machine learning. Business intelligence developer, because see, this is an area which I would say really has a lot of application and a lot of demand as we go further is going to be in this area. Like a person who understands business, who understands business data, and is able to clearly bring out where artificial intelligence can be applied, how it can be applied, and how we can get the best results and make our services and designs much more effective in the market and competitive in the market. So these are broadly the areas where artificial intelligence job profiles are there, really very highly paying, very demanding. And I think any engineer needs to know what is artificial and what are the applications. But people who really are able to, integrate their knowledge of artificial intelligence with business requirements are really going to be the people who really pick up the high-end jobs. And that's what I had broadly. The last one is a what I call video. I'll send some of this across. You guys can look at it at your own time. I'm open if you have any other questions. I would like to take them. Otherwise, we are at the top of the hour, and I would like to conclude here. Thanks for a very patient listening. Appreciate it. I sincerely hope this is. I mean, I know all of you are very well aware of intelligence. The idea is for putting everything together to make you all look at it as a one single entity and see and sort of enthuse you to pick up what really you guys want to do in your particular area. And I'm sure most of you in whatever projects, etc., you do, you will have some applications of artificial intelligence. Thank you very much, and thanks for your time.
Thank you, sir. Thank you so much for your wonderful session, sir. It's time for query session. Do participants have any queries? The resource person is now available to answer your queries.
Thank you, sir. Thank you for your valuable session. It's very informative, sir. I have one question, sir. Actually, what is the major challenges or issues in AI development and implementations?
So, from a very one of the major issues which is required today is data, right? Whenever we pick up an application or when we want to get into AI and see whether we can apply it, we really have to delve into do we have sufficient data and sufficient relevant data to our particular problem. Because what happens is sometimes we have a lot of data, but it may not be relevant to the problem we are trying to solve. So primary thing for an AI system is today is we should have a large volume of data and the ability to get more data from the customer or from whomever you want. So if the customer is closed and is not going to share any data back to you, an AI system is not really going to function that effectively, because you will not be able to train, you will not be able to make your algorithms more effective, right? So you've got to be able to have a large amount of data initially to train the system. And once we have deployed the system, we have the ability to capture back data and improve our system or hone your system or tune your system accurately. So the primary thing I would say is availability of data and ability to get data after you deploy your system.
Okay, thank you, sir.
Thank you, sir. We hope that our audience has a clear vision and understanding of today's session. Thank you so much, sir, for making this session a wonderful event. Let's wind up this evening with a warm note of appreciation. It's time to propose the vote of thanks. I would like to call upon Mr. Vishnu Priyan from the Department of Information Technology, second year, to propose the vote of thanks.
Gratitude is a quality similar to electricity. It must be produced and discharged and used up in order to exist at all. Today, I take the opportunity to put all my gratitude into words. I consider it a great privilege to propose a vote of thanks to all the dignitaries who have witnessed it as a memorable and successful event. On the behalf of K.S.Rangasamy College of Technology Institution Innovation Council, I would like to express my gratitude to our Honorable Chief Guest, M.S. Shankar, Retd VSM, ex-Director, Honeywell Aerospace Consultant Technology Strategy, for taking his precious time out and delivering a speech on the topic innovation on human intelligence and machine learning. Sir, indeed, your words have inspired us. Today webinar was full of knowledge and interesting things. It gave us deep insights into the topic and also revealed some interesting facts. Thank you, sir, for sharing with us your words of wisdom. You took this event to a great level. We will be looking forward to have more of your presence in future events. We thank you for being with us. It has remained a pronounced pleasure. I extended my senior gratitude to our Vice Chairman Sri R. Srinivasan and our CEO Dr. K. Tyagaraja sir in absentia. A special mention to our respected Principal Dr. R. Gopalakrishnan for being our constant support. With a deep sense of appreciation, we thank our loving teachers for their untiring efforts. I would also like to thank the people who worked behind the scene of make this event happen. Our president, vice president, and convener of IIC, faculty coordinators, and student coordinators. Also, thank you to all the students present here for paying your attention and learning. The essence of fruit is always tested in the last, and we believe that the last will be the best. I would like to thank all our students of IIC for working with us in making this event a memorable one for all. Thank you all.
Hey, thanks a lot, Mr. Prem. Thanks for the good word. Thank you very much. Thanks everybody for attending the webinar, and have a great day. Have a great time. Thank you very much.
Thank you, sir. Thank you all for your valuable time with us. Hope this session would have been rewarded you with valuable take-home benefits. A kind instruction we